Okay, we have quite a bit to do. I have 4 problems here for you. You will need your calculators. Get your calculators. And then by now you've turned in your credit card project to the back table. And then I have to check Friday's assignment and Monday's assignment. I haven't done that. I'm going to finally address it today. Then I'm going to let you see your text and do class correction. So it's a full class, guys. Full class. Yes, they're in. They're in. When did you put them in? Like 3 seconds ago. Oh my lordy. I just don't get everything. I'll take it. I'll just have to make sure. This is. Alright, has everybody, okay, so 2 people are still missing a textbook, but has everybody else been able to find page 555? So Natalie, you still haven't found yours, or you have? No, I have mine. So we're only missing Lee. Are you related to Nate, by the way? You're not.
It's 560 and 35, but then it says 560 with no problems.
It's both pages, which I think I shouldn't have to tell you, but people are always like, but miss, it's this page.
But like what problems on 560?
It's 33, 34, and 35. Where they are? I don't know. I think you should find them.
Oh, it just spans on the
Yeah. No, there was no homework that you had to write yesterday. All right, guys. So E is E. What does it say? What does it compare E to? What does it say that E is like when you read page 555? What is E? Have you read it yet? What is it? What are they comparing it to? Let's say it's a special number. E is special. Okay. It's similar to pi. Okay, pi is a relationship between the circumference of a circle and its radius. It's just a relationship that mathematicians notice. They notice that ratio is always 3.14 and so forth. I is something they notice that you can square root a negative and it's still useful, but it doesn't really make sense to our human brains, so we call it imaginary. This is a new one. It's called E. It's just like those. Okay, so E is not a typical variable. It stands for a number. E comes from this expression. So this is your answer to number 2. Number 1. Didn't I write? Okay, yeah. So it looks a lot like the middle of the credit card problem, the formula, right? It's 1 plus 1 over x all raised to the x. So it's very much related to like that compounding interest. So this is what I'm expecting you to write. And it's really important that you write as x approaches infinity, okay? So as x gets higher, and you put it here and here, as this becomes higher and higher, it keeps approaching this number e. Did you guys write the first 10 digits? There's a button on your calculator that'll show you what e is. Can you find the button? Can you find it's lowercase e? Go ahead and find the button. Maybe just do Wait, what says e to the x? Is it 2 point something? That's it. How do you do that? You're gonna hit your 5 on twice like that. And then 5 on 5. Oh no, you want a lowercase e. Find the lowercase e, not the uppercase e. They're two different things. So the first 10 digits. So you guys all know what pi is. What's pi? That's enough. That's enough. So now you always know that e is 2.71. 8. 2, 8. 1, 8. 2, 8. 4, 6. It never actually repeats. But this is a number, as x approaches infinity, this just keeps approaching closer and closer to 2.7. It's kind of weird, but I proved it before. All right, so now without using your button E, you guys are going to kind of observe how that number appears. You're doing A, B, C, and D with your calculator. All we're changing is the x value. So we're showing as x gets larger, doing A through D, what number you end up with. Let's go 2 decimals. Let's do 3 decimal places. Let's see what we get here. So with just a 5 in the denominator and the exponent, 2.488. With a 50, 2.69. With a 500, 2.71. And there it is, there's the 2.71. And then with the 5,000, 2.718. So we could go to 5 million next, and it would be even closer to the 10 digits, and then 5 billion, and then 5 trillion. And it keeps approaching this number. These 10, or as if it were to go on forever like pi. Just the highest number you could think of. You know? It says x approaches infinity. It doesn't end. So the higher you go, the more precise you are to that number e. These 10 digits, because this is just like your calculator full. Like it keeps going. This is just as many as the calculator could show. So if you want to fill up your calculator, I mean, just right now, try 5 million. It'll fill it. We just put 2 more zeros on there. Or that would be 3. 3 more zeros, I'm sure will do it. Now, I mismatched my zeros. It didn't work. So I got to 81801. Did anybody get a 4-6 yet? Did you do 5 million? I got this far with 5 million. So next you would try 5 trillion. It doesn't have to be 5. We could be doing 8 trillion. So anyway, as you can see, as x gets larger, you get closer and closer to that number. It's just a special number like pi. Now this is used for finance problems and even biology problems where something is changing continuously. So the bankers at some point decided, okay, we could compound monthly, we could compound daily. Daily would put a 365 in that denominator instead of a 12 from the credit card project. And then they said, well, let's use Euler's E, and we could compound continuously. Natural base E, and we'll compound continuously, which means if you use the base E, it's like you're adding interest every second. Which to the average person, there's no difference. It'll be like 50 cents difference after a year if you're compounding continuously or daily. But I guess on the grand scheme of things for financial institutions, it makes a difference. Saved. Okay, so I'm switching the script here from the credit card project. So when you use a credit card, you're charged interest, but when you give the bank money, like if you're giving the bank $4,000 and you're letting them hold it, they give you money back. So they're going to give you 5% interest for leaving your money there. Why do they want your money? So they can loan it back out. So if they're giving you a credit card and they're charging somebody to use that credit card 15% interest, and they're giving you 5% interest for keeping your money there, how much are they profiting? 10%. So the difference there is how much the bank is making. You're having to pay them 15% for your credit card, and they're giving the people saving 5%. So they're getting to keep 10% difference. So in the economy, if they're charging really high interest rates like they are for credit cards, and really low interest rates is your reward for savings accounts, that's when things are kind of sketchy. People are a little unhappy. All right, so to compound continuously, we have to use E. So this uppercase P is just your principal amount. So in my calculator, I'm going to do 3,900, and I have to use the E button. And then it's an exponent, and not every calculator uses this exponent button, but I want to emphasize that these are up high. It's the rate as a decimal times the number of years. So that's it. And it's not that common, but you could Google it right now. You could say which banks are offering savings accounts compounding continuously. And it's usually like you got to be like ready to deposit quite a bit of money. But they are offering it today. This is a real thing. So after 10 years, you have $6,430. So your money grew quite a bit. Now, not as much as the credit card grew in 10 years. If you remember your credit card amount, the 13.99% after 10 years was like, I can't remember. Can you? It wasn't this high, but for 10 years, the 13.99 that everybody did. It's kind of tough to compare because that was $1,000 on the credit card and this is 3,900. But oh, it's 0. Are you guys questioning the decimal? 0, 1. You like that one better? Sorry about that. 0, 1. All right, so your 3 problems I assigned you today are using this PERT formula. That's what we call it, the PERT formula. So if you need to take a picture of this to be successful, to do this 3 more times today, take a picture. There used to be a shampoo called PERT Plus. Anybody heard of that? The PERT test. Yep. The PERT test. You guys ready for the SAT and juniors?
I got it for a second. Natalie, I guarantee she won't tell you. I think I was. Oh, I don't worry about it. No, I did
Alright guys, get out your the word problems from Monday. On Monday I assigned you 19 to 22, 36, and 39. I'm checking it right now. Page 548. Mm-hmm.
Do you want us to answer like the questions in like complete sentences?
Do you remember what color you wrote it in? You can use Xander right now. I should just look at your graphs right now too. So the graphs from Friday, I already erased. 7 and 9, yeah.
Oh, yeah, I did that.
The date is, the 13th, February 13th. Okay, I'm gonna go to the other answers. $36 and $39. It was right above this. 547. Project. Oh, thanks. Yeah. Thank you. I sent it and it's really one. Alright guys, if you have a red pen or a highlighter, I'll be giving you your test for corrections. Does anyone got not taking this test? Have you studied, Jane? I'm taking it again. Yeah, if you're coming at us without experience, you'll be bad. Extraneous solution, composition, inverse function, index of a radical. Yeah, compare your answer to somebody else. You don't have a pencil, you can use a colored pencil, highlighter, pen. Just anything not pencil, anything not regular. If you got less than a 60 and you know you want to come in after school and do corrections, just put your test right back in the basket and come in after school. Don't do corrections right now. You can correct it up to a 60. If you would rather just get on Khan Academy and do corrections right now, because you know you can't come after school, you're not going to come after school. And then get on Khan Academy and do Khan Academy to get up to a 60. Did everybody get a test? Oh, you should have didn't grade it yet. I know, I didn't even grade it yet. I'm sorry. Okay. We'll take it early. Anybody else not get a test? Let me put up the right answers so you can check it, and then I will take questions. So each one's worth about 4.5 points, 4.5. Here's your vocab. So I have to